Something alien entering our solar system, breaking every rule written in the textbooks of astronomy, and then vanishing, leaving behind not a trail, but a riddle that refuses to be solved. Picture for a moment how the world would react if a message in a bottle washed ashore, written in a language no one could decipher. That is how scientists felt in the autumn of the year 2017, when a stranger emerged from the black expanse between the stars and swept through our cosmic neighborhood. Astronomers, ever alert to the shifting tapestry of the night, quickly gave it a name, Oumuamua. In the Hawaiian language, it means messenger from afar arriving first. The name itself hinted at its uniqueness. Yet, from the very beginning, Oumuamua refused to play by any script science had ever written. Unlike the planets and asteroids that obediently orbit our sun, this object's path was different, an arc not chalked by gravity, but by something more mysterious. It did not meander like a comet, nor did it behave like any asteroid ever catalogued. Instead, it sliced through the solar system on a hyperbolic trajectory, its velocity not of this solar system, but of the vast interstellar void. Then, just as astronomers thought they had seen it all, came a twist that stunned the scientific world. In the days before it slipped out of sight forever, Oumuamua inexplicably sped up, on its own. No rocket engines flared, no plumes of vapor trailed behind, nothing could be seen to account for this extra push. It was as if an unknown force, or perhaps even intention, was at work, propelling it away from us. So, what truly happened when Oumuamua was first detected? To understand why it shattered scientific expectations, we need to return to that electrifying moment of discovery, when the boundaries of astronomy shifted overnight. Across the globe, astronomers scrambled, telescopes whirred into action, desperate to snatch every last photon before the visitor vanished. But each new glimpse only deepened the mystery. Its shape defied precedent, long and thin, perhaps like a cosmic cigar, or maybe pancake flat. It spun wildly, tumbling in ways that defied natural stability. Even the sunlight it reflected seemed odd, unlike any asteroid or comet known. Oumuamua was no ordinary object. It was a cosmic riddle, a direct challenge to everything we thought we understood about the universe. History is full of moments when a single anomaly has shattered the boundaries of knowledge. Think of Galileo's telescope revealing moons around Jupiter, or the discovery of X-rays by Wilhelm Röntgen, which opened whole new realms of science. If we choose to look away from mysteries like this, we risk missing the next revelation that could change our understanding of reality and our place within it. Let us rewind to the autumn of 2017, when a faint streak of light first caught the attention of a telescope in Hawaii. That single detection would set off a global race to uncover the true nature of this interstellar messenger. High atop the volcanic slopes of Haleakala, the Pan-STARRS telescope scanned the night sky, searching for near-Earth objects that might one day pose a threat. On October 19, 2017, it recorded a faint streak, at first glance, just another asteroid. Yet the object was moving so quickly that it could break free from the sun's pull. This was not just another piece of space debris. It was the opening note in a cosmic mystery that would shake the foundations of astrophysics. But its behavior was even stranger. There was no glowing coma, no dusty tail, nothing to suggest it was a comet. It spun erratically, tumbling end over end, as if tossed by some invisible force. Its unpredictable rotation made it nearly impossible to track, and every observation only deepened the mystery. Astronomers turned to its shifting light for answers. As it spun, the object's brightness swung wildly, indicating that it was incredibly elongated, possibly up to 10 times as long as it was wide. Some compared it to a cosmic cigar, others to a flat pancake flipping through space. Nothing in our records looked remotely like this. Astronomers soon realized this was no ordinary visitor. It was moving at nearly 87 kilometers per second, fast enough to escape the solar system entirely, never to return. That speed alone set it apart from anything ever observed. Unlike the endless parade of space rocks bound to our sun, this object was on a one-way journey, slicing through our solar system on a hyperbolic path. For the first time, we had direct evidence of an object from beyond, a true interstellar traveler. The mystery grew deeper. Unlike most space rocks, which are dark and rough, Oumuamua reflected much more sunlight, suggesting a metallic sheen or an unusually smooth surface. Its appearance was as alien as its journey. But the real shock was still to come. As astronomers rushed to decipher Oumuamua's secrets, every new observation raised more questions, pushing the limits of what we thought possible. What exactly was Oumuamua, and where did it come from? The search for answers would lead scientists to the edge of scientific possibility and into controversy. Naming it was a challenge, too. Astronomers settled on Oumuamua, a word that not only signified a messenger, but also someone who enters a room ahead of others as if to prepare the way. Fitting, because this was the first object from interstellar space ever detected in our solar system. Missing it would have meant losing a once-in-a-civilization opportunity to glimpse the unknown. Asteroids were next on the list, but asteroids do not suddenly speed up, and Oumuamua's shiny, rapidly tumbling surface did not match any asteroid ever seen. Each familiar answer proved hollow. The mystery deepened with every failed theory. The scientific world was electrified. Explanations raced in. Was it a comet, venting invisible gas? Normally, sunlight heats comets, causing jets of vapor that act like tiny thrusters. But Oumuamua showed no tail, no dust, not even a wisp of gas. Nothing, even under the scrutiny of the world's most sensitive instruments. Objects in space do not move faster on their own. Something, or someone, must push them. This is what made the arrival of Oumuamua in 2017 so shocking. Spotted as it zipped through our solar system, Oumuamua was the first confirmed object from another star. Astronomers expected it to slow after skimming past the sun. Instead, it accelerated, gaining speed, slipping away with a final inexplicable burst. Desperate for answers, scientists got creative. Could it be sunlight itself pushing on Oumuamua, as if it were a cosmic leaf caught in a faint breeze? This effect, solar radiation pressure, could work, but only if Oumuamua was astonishingly thin. Nothing in nature, at such a scale, is known to be that delicate. Every new theory was like patching a sinking ship. Plug one hole, two more opened. The universe seemed to be mocking us, guarding its secret. A few researchers suggested a hydrogen iceberg, a chunk of frozen hydrogen, invisible as it sublimated into space. But hydrogen ice could not survive the long journey between stars. Others floated the idea of a dark comet, its surface coated with carbon-rich material that masked any signs of outgassing. Yet once again, the evidence did not fit. Yet debate flared. Yet the more scientists investigated, the more the enigma grew. Oumuamua forced them to challenge assumptions, to admit the limits of their models, and to consider that nature, or something else, could be more inventive than ever imagined. Then, a truly radical idea broke the surface. Avi Loeb, a Harvard astrophysicist, proposed that Oumuamua might be alien technology, a light sail crafted to travel on the push of starlight. The public was captivated. Many scientists, though, balked. They demanded extraordinary proof for such an extraordinary possibility. But Loeb refused to let the unknown be dismissed. He and his colleagues launched Project Galileo, a systematic search for physical evidence of extraterrestrial technology. For the first time, mainstream science invested in finding not just distant radio signals, but actual objects, artifacts that could drift through space for thousands, even millions of years. But the story of Oumuamua is not just about one strange visitor. Its mystery has changed how scientists look at the universe and what they are willing to imagine. What if Oumuamua was only the first of many? What if cosmic visitors like it are far more common than we dared imagine? Historical parallels abound. When astronomers first saw the canals of Mars, many speculated about alien civilizations. When pulsars were first detected, their precise signals were jokingly nicknamed LGM for little green men. Each time, the universe forced us to separate imagination from reality, but only after we dared to ask bold questions. If we let old beliefs blind us, we risk missing discoveries that could reshape our place in the cosmos. We might turn away from truths that could redefine everything, all because they do not match our expectations. Remember, for centuries, astronomers believed the heavens were unchanging, until supernovae and comets proved otherwise. Letting go of dogma is how science advances. One such oddball, a small asteroid called 1998 KY26, is about to have its secrets pried open. In the early 2030s, Japan's Hayabusa 2 mission will intercept it, offering a rare opportunity to scrutinize a mystery object up close. Such missions hold the promise of revealing whether these cosmic drifters are natural relics or something even stranger, perhaps alien in origin or design. Since Oumuamua's brief brush with Earth, astronomers have wondered whether our solar system is a frequent crossroads for interstellar travelers. The evidence is mounting. In recent years, at least half a dozen near-Earth objects have exhibited strange non-gravitational accelerations, sudden nudges that defy what gravity alone should allow. Each time, scientists are left pondering, are we witnessing a parade of outsiders slipping through our celestial front yard? Imagine the possibilities if Hayabusa 2 were to find an object with metals rarely seen in the solar system, or with isotopic ratios that only form around distant stars. Such a discovery would echo the surprise of finding meteorites on Earth that originated from the Moon or Mars, shocking at first, but ultimately rewriting what we thought possible. The intrigue deepened in 2019 when astronomers confirmed a second interstellar visitor, Comet Borisov. Unlike Oumuamua, Borisov flaunted a brilliant tail and a chemical makeup unlike anything found in our own solar system. Its alien recipe was a stark reminder that the universe is vaster and more unpredictable than our textbooks suggest. Oumuamua, it turns out, may only be a hint of what lies beyond. All signs now point to a profound truth. Our solar system is not an isolated island, but a bustling intersection where galactic debris and perhaps messages pass through far more often than we realized. The odds of finding two interstellar objects within just a few years are so slim that the galaxy may be teeming with these cosmic nomads. Yet, Oumuamua's origin remains a haunting mystery. It could have drifted through the void for millions, even billions of years before catching the sun's attention. Was it born in the fiery chaos of another star system, or shaped by processes unknown to us? Its visit was so brief, our instruments barely captured a handful of clues before it vanished forever, reminding us how unprepared we truly were to seize the moment. For centuries, these visitors may have slipped by, unseen and unremarked. Early astronomers like Tycho Brahe and Johannes Kepler, working with primitive lenses, could not have detected such fleeting travelers. Only now, with sweeping sky surveys like Pan-STARRS and the upcoming Vera C. Rubin Observatory, are we glimpsing the true scale of this cosmic migration. The implication is staggering. We have likely missed dozens, perhaps hundreds of interstellar interlopers. There is a danger in waiting, in assuming that we will always get another chance. Without sharper technology and a willingness to question our assumptions, the next cosmic revelation could slip by unnoticed. Each missed visitor is a lost opportunity, a chance to answer humanity's oldest questions. Where do we come from? Are we truly alone? What else is out there, waiting to be discovered? Imagine if the Rosetta Stone had been lost before it was deciphered, or if we had ignored the faint signals of the first radio pulsars. Each time, it is only our curiosity and preparedness that turn fleeting encounters into paradigm-shifting discoveries. The universe is sending us messages, but are we listening? The next chapter demands that we look up and prepare for the unknown. We let Oumuamua slip away, a silent messenger from another star, and all we could do was watch. The experience was a vivid reminder that our tools, and perhaps our imagination, were not ready for the unknown. Think of it as the 21st century's answer to the race for the South Pole or the moon landing, a quest to reach the unknown before it is lost. The stakes are just as high, the chance to reshape our understanding of the universe. Now, scientists refuse to be caught off guard again. Project Lyra is in motion, an audacious mission designed to chase down Oumuamua or its successors in the vastness between stars. By using intricate gravity assists and daring solar flybys, the plan is to catch up, not just stare helplessly from afar. Up close, we might finally learn what these interstellar travelers truly are, whether natural wanderers or something much stranger. But the hunt does not end there. In the mountains of Chile, the Vera C. Rubin Observatory is about to awaken. Its powerful eyes will sweep the whole southern sky every few nights, searching for fleeting visitors. Astronomers expect to find not just a handful, but perhaps thousands of interstellar objects each year, far more than we ever imagined, each one carrying secrets from beyond our cosmic backyard. Europe is preparing too. The European Space Agency's Comet Interceptor will wait patiently in space, engines ready. If another interstellar object plunges into our solar system, it will launch in pursuit, determined to meet this cosmic stranger head-on. This spacecraft is science poised on a knife's edge, alert, responsive, and determined to capture the unknown before it vanishes again. All of this urgency is driven by a startling possibility. Interstellar objects may be common visitors. Some estimates suggest that thousands pass through our solar system every single year, almost all unseen. Oumuamua was likely just the first to be noticed, not the first to arrive. If we stand still, we risk repeating the same mistake, letting secrets that traveled for light years slip right past, leaving us in the dark once again. But what if the answers we seek are even stranger than we imagine? The universe may be waiting to surprise us, and the clock is already ticking. The universe does not pause for our convenience. Each new mystery might be waiting just out of sight, closer than we dare imagine. To grasp the next chance, we need more than improved technology. We need a new mindset. Oumuamua's legacy is not just an unanswered question, but a challenge to our complacency. It dares us to embrace uncertainty, to let curiosity lead us into uncharted realms, and to prepare for discoveries that could overturn everything we believe about the universe. When the object called Oumuamua swept through our solar system, it left us with riddles instead of answers. Its presence shattered our scientific expectations and exposed the boundaries of what we think we know. The true impact of Oumuamua is not in its identity, but in how it forced us to grapple with uncertainty and humility. We are standing at the threshold of a new era of cosmic discovery. What we choose to do now will shape whether we greet the next mystery with hesitation or with wonder. Every unanswered question it left behind is an invitation to push further. If we only search for what we already expect, we risk overlooking discoveries that do not fit our narrow frameworks. The real danger is in turning away from the unknown, because then we risk losing the chance to uncover something genuinely groundbreaking. But if we prepare, by designing sharper instruments, launching ambitious missions, and keeping our minds open, we give ourselves the best chance to meet the unknown head-on. Oumuamua's greatest legacy is not the comfort of explanation, but the disruption of mystery. It demands that we remain curious, skeptical, and above all, alert. The cosmos will not wait for us to feel ready. It will continue to send visitors, some ordinary, others utterly alien. The next messenger could appear without warning, carrying truths even stranger than before. Practical steps are already in motion. The astronomical community is advocating for increased funding and international collaboration to develop rapid response missions so that the next interstellar visitor does not slip by unexamined. Universities are training a new generation of scientists to think beyond traditional models, to recognize outliers and pursue unconventional evidence. Imagine a future where a network of satellites watches every corner of the sky, prepared to launch microprobes at a moment's notice. Imagine a world where the discovery of interstellar objects becomes routine, and each one brings us closer to understanding our galactic neighbors. Technology is advancing at a pace that would have stunned even the visionaries of the 20th century. Machine learning algorithms now scan sky survey data for anomalies in real time. Multi-wavelength observatories can dissect the chemical fingerprints of passing objects, searching for telltale signs of non-natural origin. The public, too, plays a role. Citizen science projects invite anyone with an internet connection to help spot the next cosmic anomaly. Historical perspective reminds us what is at stake. When Edmund Halley predicted the return of his namesake comet, he proved that the universe is not as random as it may seem. When Jocelyn Bell Burnell discovered the first pulsar, she opened a new window on the cosmos. Each time, it was the willingness to question, to pursue the unknown, that led to a leap in understanding. So, as we look to the heavens, the question is not simply, what was Oumuamua? But rather, are we ready for the next messenger? Will we meet it with skepticism, or with the courage to follow wherever the evidence leads? The debt of unanswered questions left by Oumuamua is not a burden, but a gift. It is a call to adventure, a reminder that the universe is vaster, stranger, and more wondrous than we have yet imagined. The next chapter is unwritten. The choice is ours, to wait in comfort or to reach for the unknown. As Oumuamua vanishes into the deep, it leaves behind a challenge and an invitation. Will we answer?